Okay, we'll keep moving along, I guess. Up next we have, lose my place here, Jason Cook is with us from Montana. He's on the spring wheat breeding side. I'll let him take over from there. Thanks.
Check, check. All right. All right, well, thanks for having me here. I'm the new spring wheat breeder at Montana State University. I just took over for Luther Talbert, who retired back in 2019, this past September. So I'm originally from north central Montana, and so I've definitely been through this region a fair amount of times, and definitely be looking forward to being up in this area in the coming future. So today what I'm going to do is talk a little bit about what we're doing as far as the Montana Spring Wheat Breeding Program, some of the different breeding objectives that we're focused on, and also going to provide some yield data just so you can see how some of the different varieties that we're testing are performing in our state and might have some overlap here into North Dakota. First, just want to do a quick overview about what plant breeding is, and just kind of review some of the terminology that we use in plant breeding. The first thing I want to just define what a gene is. So a gene is a DNA sequence that provides a genetic code to produce a protein that controls a trait. A trait is an example of a trait is something like eye color. And then you can have different variants of these genes, and these variants, we call those alleles. So these are just slight changes in the DNA sequence that causes trait variation. So if you use the example of eye color, so you can have one allele that causes blue eyes, and then you can have another allele that causes brown eyes. So that's how we get variation for different traits. So what plant breeding does is we can take a variety, or well, two varieties, and each one of them has a unique allele combination. We take those two and then we cross them together to produce a population that generates new lines that have unique allele combinations that's really never been seen before. And then we put them out in the field, test them, see how these lines perform, and then if they're performing better than the varieties that you're already growing, we'll release those lines to the public as a new variety. So the way our spring wheat breeding program works, the first phase of the breeding program takes 3 years. So that involves making the initial cross, and then we do some population development, from which we then derive new elite or new experimental lines that will then go into a testing phase, which takes 5 years. And at the end of the 5-year testing phase, if the variety is if the experimental line is performing better than the varieties that are already out there, or it carries a trait that you need, say for a disease or a pest, we'll release that to you, the farmers. And then additionally, so this is the pipeline, the center part. And here's the laser. So this is the pipeline, and it's actually cyclical. So each year, after our initial yield trials, we'll select the experimental lines that are performing the best, and then we'll use those as new parents. We'll make crosses the next year, and so then that allows us to have a continuous flow of new experimental lines going through the breeding program each year, from which we can, possibly might release a new variety to the public. So one big focus of ours right now, since I've started, is we're working on expanding our yield trial testing. Reason we're doing this is because the more data we have in our key spring wheat growing regions, especially in Montana, the more data we have, the better we're able to predict how these new experimental lines perform on the farm. So we want to get as many trials out there to capture as much data as possible, so we have the best idea of how these varieties are performing out in the field. So what we've done is we've expanded the number of locations in which these breeding trials are located. So Our preliminary yield trial, we've bumped that up from 4 environments to 10 environments. Our advanced yield trial, we bumped that up from 8 environments to 12 environments. And here you can see on the map where these are located. And part of this increase, we've also, for the first time, we're starting to test here at Williston at the NDSU Research Center. The reason we're doing that is because we're definitely short on locations up in this key northeast spring wheat growing region, so we're trying to get more trials into this area. And NDSU has a great testing program here at the Research Center. Our winter wheat breeding program has been here for a number of years, and so we've added our program. We're sending trials up here as well. And in the future, we'd love to get more trials up in this area, but right now we're just limited to finding, well, we can't find anyone that has the testing capacity to do more testing in this area. So we're going to keep working on that, trying to identify people who can do more testing in this region, and then we hope to get more data out of this area as well. And then finally, we have this set of elite off-station nurseries, or also known as on-farm yield trials. And what these are, as the name implies, are yield trials that are placed in farmers' fields. And generally, our most elite breeding lines or most widely planted varieties are in these trials. And so it gives us a better sense of how these different varieties and experimental lines are performing on farms. And so before we release a variety, we'll have some sense of how these varieties are doing in the real world. So with that, I wanted to go over some of the data that we got from this last year. Obviously, it's going to be very difficult for most of you to see these numbers, but there is a handout in the back, and hopefully some of you have this handout. So this table is on the front page of that handout, and then on the back page is my next slide. So if you have that handout handy, you could just follow along on that. And then there's also a QR code at the bottom of this. So these tables are just a subset from our annual report. If you screen or scan that QR code with your smartphone, you can that'll send you to the link where our full report is, and that it contains data on each location for this last year, and then also multi-year averages and so forth. So you can use that handout to get all the information, get the information that we have to help you make decisions on what varieties you might want to grow. So what I have here, showing the 2021 yield trial data from this last year. These are averages from 10 dryland locations. I thought it'd be valuable to show this because it gives a good sense of how these different varieties compare how they perform under severe drought conditions. And then the other thing I have on here is I included soft fly data, soft fly cutting data, as well as solid stem scores. I was in the area doing field days this last summer, and a number of farmers have indicated that they're seeing uptick in amount of soft fly that they're seeing on their farms. So I thought I'd show some of this data just so you can get a sense of what we're seeing far as soft fly resistance amongst the different varieties and how they're performing in different locations and so forth. So historically, breeders have generally published solid stem scores as a proxy for how resistant a variety is to soft fly. However, that's not it's not exact. There's still quite a bit of, even if a variety is pretty solid, you still can see cutting in certain years and in certain environments. So we're really focusing on trying to get the actual soft fly cutting data, and so we can get a better feel for exactly how these varieties are, how resistant they are to soft fly. One thing I wanted to show as just one good reason why we want soft fly cutting data along with the solid stem scores is, for example, this variety called WB Gunnison. It has a relatively low solid stem score. So solid stem scores go from 5 to 21, where 5 is hollow, 21 is the most solid score you can have. This Gunnison line has a solid stem score of 11.8, but then you can see from the soft fly cutting data, it had the it was the most resistant line in this bunch. And I'll go into a little bit why that is. And then secondly, if we look at this other variety, this variety called AAC Concord, this is a first year we've tested this variety, and it's out of Canada. And it had the highest solid stem score, and it also had pretty good, it had the second best soft fly cutting resistance. So just by looking at the solid stem scores alone, it won't give you the full story of how resistant these different varieties are to soft fly. Next, I'll just kind of focus on a few of the varieties that's been released by the Montana State Spring Wheat Breeding Program. First is a variety called Lanning. So one of the big focuses of the breeding program is to develop varieties that have the yield potential of Vita, which is right here. It's the most widely planted spring wheat variety in the state of Montana. This last year is around like 23% of the total acres. So a big focus of the breeding program has been to release a variety that has similar yield potential as Vita, but with improved grain protein content and in-use quality. So Lanning was one of the first varieties released towards that effort. It definitely has higher grain protein content, and it also has better end-use quality, but it doesn't quite have the yield potential that Vita has. The one thing it does have over Vita is it does have aluminum tolerance, and people have actually been pretty interested in growing Lanning for that reason, because in Montana we're seeing an increased problem in high aluminum issues in some of our growing regions, and then my understanding is there's some of those issues in western North Dakota as well. And so we've seen people buying Lanning to plant in some of these areas that have the aluminum problems. So we have Lanning, and then another variety that was released in 2019 is called Dagmar, and as you can see, this variety has quite high yield potential. It's in the top yielding group with Vita, and it also has pretty good wheat stem softfly resistance as well. The big thing with Dagmar is its grain protein content compared to Vita. It's at least 1% higher grain protein content than what Vita has. So from that standpoint, especially in a year like this where fertilizer prices are at a premium, a person may want to grow a variety that has this higher grain protein content if you can't put down quite as much fertilizer as you typically would in a normal year. And then lastly, MT Sydney. This was a variety that we released this past year. And we released this one because it's one of our first variety. We have some moderate FHB resistance in it, so this has become another focus of our breeding program. I'll talk about it a little bit more here in a little bit, but we did release this one for its FHB resistance and then adaptability to Montana's growing environments. Then lastly on this table, two lines we're moving forward and we'll be considering for release at the end of this next growing season is this MT 1939 and MT 1809. MT 39 has performed really well under these drought conditions. It was also included in a regional trial that included total of 12 locations, where a lot of those locations were in North Dakota, Minnesota, South Dakota, and it was a leading variety across all those trials. And it's pretty rare for one of our Montana lines to top that trial, because in normal years, our lines generally don't have the disease resistance that are required, like especially in eastern North Dakota. And so they typically burn up due to the disease pressure. But due to the dry conditions this year, these lines did pretty well across all the states, since disease wasn't as big of an issue this year. So moving on, I'll just briefly kind of go through this table since you can't really see anything on here, but the main thing I wanted to point out is across multiple years. So we also like to look at yield trial data across years to get a sense of how stable the yield potential of these varieties are. And you can see our new variety Dagmar is right there at the top, right along with Vita. Of course, once again, the big difference between these two is Dagmar has approximately 1% higher grain protein content than Vita does. So that's the big, and the end-use quality is much better as well. So, so we're pretty excited about Dagmar, and we think it has quite a bit of potential as being a good variety for producers to grow. Then down here are the 2 experimental lines that we're going to be considering for release after this next growing season. And the way this table is organized is, this first column is the 4-year averages, and then the varieties are sorted based on highest to lowest yield. And then the second column is the 3-year average, and so forth. And then they're sorted with, with the varieties that are just like been grown for 1 year or 2 year or 3 year and so forth. So moving on, as I mentioned, we're starting to focus on Fusarium head blight resistant varieties more. And this is being supported by the U.S. Wheat and Barley Scab Initiative. So they're helping. The biggest thing they're supporting is screening nurseries, where we send our experimental lines to locations that are mist irrigated and inoculated with FHB, and then we use these screening nurseries to identify lines that have lower FHB incidence and lower DON levels within these varieties. So we've been working with Frankie Crutcher, who's based at Sydney. She has our spring wheat screening nursery is located at Sydney, and then our winter wheat screening nursery is located down in near Billings. Reason it's down there is because we get too much winter kill up in this area. So Billings has a much milder climate, and it's warmer too, which is more conducive for FHB infection. And we've actually had pretty good success in that environment for these screening winter wheat in that area. So from these efforts, as I just mentioned, we released MT Sydney because it showed, having some moderate FHB resistance, and then of course it was performing pretty well agronomically as well. And then, this is just a table, a little snippet of some of the FHB data we have, and so it's quite a bit better than the other varieties that's been released by the Montana State Breeding Program. And then here we have SY Einmar as a comparison to kind of show how it compares to Einmar as far as FHB resistance goes. So moving on, I thought I'd talk a little bit about some of the research that we've been doing that's supporting our breeding efforts. Of course, the big one in Montana is wheat stem softfly, so we're doing a lot of work on that still. Just thought I'd do a little bit of history on the sources of wheat stem softfly resistance. The primary source is from this Portuguese landrace called S615. This was identified back in the 30s as having resistance to wheat stem softfly, and it was found to be due to having pith or solid pith in the stems, or known as solid stems. And so most of the varieties we have, the lineage comes from this S615 Portuguese line. But there is another lineage as well that also has wheat stem softfly resistance, and this was some material that was first selected out of a population down in Arizona back in 1978 by the Western Plant Breeders, which is now known as Westbred and owned by Bayer. And so they identified some materials that was resistant to softfly in Montana, and one of those plants that was resistant, they selected it and released that variety, and that variety was named Rambo. This variety was pretty successful in Montana. It was grown on over 5 million acres in the state in the 80s to 90s. And then from Rambo, there's been additional lines released. So one of them was called Conan, which was released in 97. And then 2 more, Corbin and WB Gunnison. And Gunnison's the one I just talked about previously that had that really low solid stem score, but pretty good resistance. And so it was a bit of definitely a conundrum why these varieties are resistant to softfly, until someone decided to look at how solid the stems were early in plant growth. And so this is before heading. And what was found is these varieties like Conan and of course the Corbin and Gunnison are actually quite solid early on in plant development, and then that solidness disappears. It's pretty much gone by the time the plants reaches heading, heading time. And so the sollenness in spring wheat anyway actually helps protect these varieties during the peak emergence of the softfly in the field. And so when the softfly go out into the field and they try to start infesting the stems, they're infesting stems that are pretty solid. And so that sollenness is providing resistance during the peak emergence of these softfly out in the field. And then, of course, that translates to substantially reduced cutting from the wheat stem softfly at the end of the season. So additional research was done on this, and some of that research involved, or what we did is we put this, we're calling the this early sollenness allele. We put it into varieties that had what we call the rescue allele from the rescue lineage. And so when we did that, we found that the infestation level, the comparison of infestation between plants that have the rescue allele and then the early sollenness Conan allele was significantly lower, and then the level of cutting was not significant, but numerically it was a little bit lower as well. Then we did the same experiment where we put this early sollenness allele into a hollow line, and we saw significantly lower infestation and significantly lower stem cutting in both genetic backgrounds that we put this early sollenness allele into wheat variety. So in spring wheat, so we've been able to identify where this allele is located. We have genetic tools to track it, and we've incorporated it into our breeding program. So we have both this, I guess you call it mode of action for resisting softfly resistance, as well as the more standard, very solid alleles for softfly resistance. So we're using both now, and we'll see where that goes. And so we have more tools in the toolbox for softfly resistance. There's still definitely work to do. So that data I was showing you in that table, some of that was from Havre, and the other location was Fort Benton. These locations got hammered this last year. But what was interesting, and so there's still a lot of work to do, but what's interesting is planted right beside these spring wheat trials, there were durum trials, and overall these durum trials did not get cut nearly as bad as the spring wheat trials did. And we've seen this in other studies as well, and so we think there's a lot of opportunity in durum, or opportunities to mine durum for additional softfly resistance alleles. And so what we're doing is we're screening durum material, trying to identify where these resistant genes, alleles are located, and then what we want to do is then pull those into spring wheat and winter wheat, and then have that as another source of wheat stem softfly resistance in our breeding programs. So my final thing I'm going to talk about today is the stay-green trait. I don't know if any of you have heard much about this before. I know a lot of you are probably familiar with the variety reader. So the stay-green trait was first identified by my predecessor. Well, other people saw it too, and my predecessor had a real interest in this because back in the 90s when he first started testing this variety in Montana and noticed this, it stayed green quite a bit longer than other varieties, and then also had a significantly higher yield potential, especially under drought. And so we coined this trait, the stay green trait, and basically what it is it just has an elongated grain fill period compared to other varieties that were grown at the time. And so then the question became, can we select the stay green trait as a proxy for developing varieties that have improved drought tolerance? So with those efforts and additional studies, this is just showing the relationship of the stay green trait to yield under rain-fed environments. So you can see there's a strong relationship between stay green and increased yield. And then this trait also increases test weight, 1,000 kernel weight, seed diameter, especially in rain-fed environments, and then also it has some impact in irrigated environments as well. The one downside to this trait is what we've observed over the years is it does have a negative impact on quality. And so this has been a big focus of the breeding efforts, is to still maintain this stay green trait or elongated grain fill period, but then improve the end use quality. And so one reason we think the end use quality is worse in these stay green traits than your standard, or in varieties that have the stay green trait versus more standard lines, is these varieties that have the stay green can have pretty late maturity. And due to that late maturity, that can cause these varieties to be exposed to more adverse weather, especially if you have a cool, wet season. And so these varieties can just kind of hang around for quite a while out in the field and delay harvest. So our breeding effort is to maintain this elongated grain field period, but select lines that have an earlier heading date so that these varieties mature earlier. And so with this breeding objective, so Lanning and Dagmar were released from those efforts. And here's just some figures showing the results of that work. So you can see on the left figure is the heading date, and on the right is maturity. This is just from Bozeman's, pretty representative of what we see across the state. But Lanning has quite early heading date, and then also matures quite a bit earlier than Vita does. And then you look at the end use quality. So Vita is definitely the worst compared to these varieties that we're comparing to. Vita has a worse quality, and then we're seeing improvement in quality with these varieties that have the earlier maturity. So this is another focus of our breeding program, is to continue maintaining this stay green trait for drought tolerance and its positive relationship to the other traits, but then bringing up the end use quality of these varieties as well for our overseas buyers and end users. So with that, that's pretty much all I have. Obviously, this is a huge team effort from the research centers, all the breeding staff, and then of course this work is all a lot of this work is funded by the Montana Wheat and Barley Committee, and then we also get support from the USDA, including the U.S. Wheat and Scab Initiative. So if any of you have questions, I'd be happy to try to answer them, or be happy to visit with you all, during the rest of the day. So thank you.
Any questions for him? Oh, hold on, we got two people talking at the same time. Sorry, Audrey. I'll give you a mic.
Are you doing anything with the durum varieties that were originated out of Sydney and kind of moved into Bozeman, or is that all done?
Yeah, no, actually Mike Giroux's taken over that program, and so he is he's taken that program, and he's actually released up to now like three new varieties from that program. So there's an active durum breeding program in Montana now, or continuing on.
So the variety Egan was mentioned today for being midge resistant, and it includes 10% refuge in the bag. And I'm wondering what that 10% is, and then does that mean that you can't save and reuse that seed?
So that 10%, I think it can be any variety that doesn't have the SM1 gene, which provides the orange wheat blossom or orange wheat midge blossom resistance. Far as reusing, how many generations can you reuse that seed? I'm not exactly sure on that. I would have to look at the paperwork to see if you can brown bag that seed and then grow it again the following year, or if you have to go back and get an additional or get a new supply of seed. If you keep doing it too long, that ratio has a potential to change, and so to maintain the ratio at the optimum level, you might off the top of my, you might want to just do it 2 to 3 years, but I'd have to look at the paperwork just to see exactly how many is allowed in the description. Anything else? Yep. Yeah, so that variety.
You want to repeat the question so everyone else can hear it too?
The question was, have we looked at any of the Canadian solid stem varieties? So the only one I'm familiar with is the one we just tested for the first time this year, is that AAC Concord. And that one, had very high solidness and was, at least this last year across those different environments that had soft light cutting, was the second most resistant variety to softfly in those trials. But I haven't looked at the other, or we haven't tested those other ones.
Okay, well, we have lots of time, so if someone does think of questions, I guess holler out, but if not, thank you.